In this video, we're going to take a look at two patterns of right triangles where we really only need to know one side length and we can find the other two. This is a little bit different than Pythagorean theorem because with that theorem, you need two sides in order to get the third side. So the first pattern is called 45, 45, 90. And this is an isosceles right triangle. So if both angles are 45 and 45, or if both acute angles are of a right triangle, that implies that it's going to be an isosceles triangle. We saw this back in chapter 4. And so if you actually play around with this a little bit, you can use Pythagorean theorem to determine that you'll always get this pattern that the legs are going to be congruent. They'll be the same exact length, and then the hypotenuse will be that exact same length times the square root of 2. So that's our first special right triangle pattern. The second one is called a 30, 60, 90, and it's a little bit different. The way that we come up with a pattern for this one is we take an equilateral triangle and we bisect one of the angles with an altitude. And if you do that, you're going to come up with this pattern. The 30-degree angle over here at C, if you keep in mind, the bigger the angle, the bigger the opposite side, and the smaller the angle, the smaller the opposite side. So in this triangle, angle C has got to be 30. If you use some arithmetic there, all the angles add to 180, so angle C has to be 30. That means that the shortest side of this triangle has to be the opposite side from angle C. So that would be AB. That's what we call the short leg. Remember that the legs form the right angle, and the hypotenuse is always opposite the right angle. So your short leg is always opposite the 30-degree angle. Opposite the 90-degree angle, your hypotenuse is always going to be that same length of your short leg multiplied by 2. And then the short leg times the square root of 3 is going to give you the length of your longer leg. So AC is going to be whatever the short leg is times the square root of 3. So this is a pattern, which means anytime we have a 30, 60, 90 triangle, if we know, say, the short leg, if the short leg was, say, like 5, then BC would be 10 because that's twice 5, and then AC would be 5 times the square root of 3. So it's really convenient to know that short leg. So two quick examples here. Let's say we have this triangle here, and they're telling us to find the value of X, and it should also say, and the value of Y. So looking at this triangle, we see a right angle with that right angle box. We see a 45-degree angle, which means that the third angle also has to be 45. So this is a 45, 45, 90. That means that the legs have to be congruent. So X has to be 7. And then Y, being the hypotenuse, is going to be 7 square root of 2. So again, that pattern, leg, 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 square root 2. Now looking at a 30, 60, 90. Here, supposing that BC is 14, we want to find all angles and sides. Well, obviously, angle C, again, is going to be 30 degrees. Now, if BC is 14, we want to identify, is that the short leg, is that the longer leg, or is that the hypotenuse? And that'll help us see the pattern we can use. So BC, that's our hypotenuse, and we know that that's always double the short leg. So that tells us that AB is going to be half of 14, which is 7. And then AC is that same number multiplied by square root 3. So the key on both of these is really to figure out what the legs are, and that kind of helps you find all of the other information. With 30, 60, 90, you want to find that short leg. And with 45, 45, 90, either leg is fine because they're the same. So again, back at those patterns, leg, leg, leg square root 2 for hypotenuse of 45, 45, 90. And then short leg is opposite 30. Short leg root 3 is opposite 60, and then short leg times 2 is opposite 90. And those are the two patterns that we need to get down here in section 8.3.